Imagine having a Kindle that isn't a visual Kindle, but instead has a tactile surface that can be read by a person who's blind using Braille. So in this project, what we're aiming to do is to create a full-page Braille display that can be refreshed under computer control. Refreshable Braille displays do exist, but they have a number of problems. The first is that they only display one line of text at a time. So if you can imagine trying to read a book on a Kindle, one line of text at a time. The second is that they're extremely expensive. A single line of Braille typically costs between $3,000 and $5,000, and a full-page Braille display would cost somewhere in the region of $55,000.
Blind people currently only have access to a single line of Braille with these digital devices, and you can't do much with a single line. It's hard to read, for one, so that's a pain point, but also you can't do things like graphs, you can't do spreadsheets, you can't do any kind of spatially distributed information. So what we've done is we've created the same dots that are created with these old displays in a new display format.
So one of the advantages with our display is that it's entirely pneumatic, which means that we can either drive it with air or fluid. In practice, what that means is we have a series of bubbles which are either inflated or not inflated, and those bubbles in turn push dots up and down. That means that we're able to produce a display that's a lot cheaper than existing displays which rely on electronics. So we never have to worry about wiring, we never have to worry about assembling individual mechanical objects. We just build up layers of bubbles effectively.
Let's say you want to create a full page of Braille, which is what we're intending to do. The thing that's been the difficulty is how do you control all the features that you're creating? That could be anywhere from 5,000 to 10,000 dots. So now you have 5,000 to 10,000 valves that you need to control on and off. How do you create such a device that has that many physical control features without it being so large that you can't carry it around? So we have a potential solution for that problem. And what that would enable us to do, in a nutshell, is to control all these 5,000 to 10,000 features in a very small space, so it could be packed in and portable and could be feasibly built.
We really feel that one of the consequences for blind people of not being able to access Braille is that they're limited in terms of the kind of scientific and mathematical things they can do in their access to spatially displayed information, and even being able to do something fun like see a graphic that represents the performance statistics for their football team over the last year. That's something that people with vision do all the time, and it would be really nice to think that we could actually bring that back.